Welcome to Chapter 2 of Soil Science and Management. Today we're going to discuss soil origin and development. Right now we're going to get more into how these soils form and where they come from and how they develop from the bedrocks and the other rocks that we have on the Earth's crust. So today's objectives, we'll be able to define the soil body. We'll be able to list examples of the 5 soil forming factors. We are going to learn how to describe how these soils develop, and we're going to be able to describe the different horizons of the soil profile. Especially important is the last one there. Soil profiles are very important to understand how a plant interacts with the soil. So once you understand the different soil horizons and how those soils interact with the different layers in the profile, you can then understand plant nutrition a lot better. When we start talking about soil formation and understanding different types of soil, we need to discuss something called pedology. Pedology is also known as the soil genesis or soil classification mapping. This would be very similar to, say, taxonomy in plants or in animals. And these techniques were developed in Germany and then were brought to the United States, and they were also had some roots in Russia. Basically, what you're doing with these different soil genesis maps are you're understanding where different soils were formed using different rocks and how those different soils uh, break down on the mineral level, and then you can understand how those soils will carry nutrients or will have undesirable materials in them. Here locally, we have natural forming arsenic that can contaminate our soil and our groundwater, and this can become an issue because then that arsenic can get into your vegetables. Obviously, these are low levels, but if you were to have this in an area with more arsenic, where you have a higher concentration, then more of that material, more of that chemical would be transferred into your foodstuffs, and then you could have a problem. So understanding where your soil came from, the things that are in it is very important. And there are people who do this for a living. They basically go around the earth, they test soil, and they map it, and they put these into different classifications so that everybody can understand it better. When we start to understand the pedology or how we start to look at this, we gotta start looking at the soil body, and uh, we start with the pedon or the pedon, and this is like a section of soil. So this is basically like an area. Take for example, like your house property. That could be one section of soil if it was all a homogeneous type of soil. What would then happen is if you have different areas of different soil formations, uh, you could then collect all those together into the polypedon. Now, here's the thing: is there's really no homogeneous soils anymore. Through natural occurrences and human interactions, most of the soils that we have uh, are just mixed up. Obviously, when we're talking about, say, like farmland, Midwest farmland, this has been stirred in and stirred in and stirred up, and everything just becomes one big hodgepodge of all the different types of soils. So you could have many different origin soils that are right next to each other, and it's just really hard to determine what type of soil you're dealing with. Now, when we talk about weathering, this is when we're talking about weathering, we're talking about how the soil forms, and the two these two methods are the most common methods for say rocks or bedrock to turn into soil. So when we're looking first at physical characteristics, this is things that are happening that are basically a natural occurrence or a human interaction. So something called frost wedging is when you have a rock that has holes or cracks, and water will get down into these holes or cracks. It will freeze, and we all know that when water freezes, it expands, and this will then crack those rocks into smaller pieces. So this could happen on a large scale with a big huge boulder, or this could happen on a very small scale with small gravel or pea gravel, or even smaller like sand particles could have this happen. Uh, Other things that can affect it are temperature. So hot, cold, those can affect soil. Water can wash away parts of soil. So this is called erosion, where you can take parts of a rock and it could be washed away in a river. And then wind is an interesting one, because wind can take already formed soil particles and pick them up and beat them against other rocks, and then you're creating a sandpaper-like effect with the wind uh, uh, exposing more of the soil. Uh, Got to go visit the Grand Canyon with my kids, and it's pretty interesting. You have the Colorado River that did a lot of the forming of the Grand Canyon, but you kind of forget the effects that wind erosion has on forming a lot of that canyon as well. It's very windy there. You have a lot of weather that can get into that area, and it can really exacerbate the erosion that the water started and the wind kind of finished. And you can tell there's areas where the water wasn't getting to, but the wind was definitely doing a lot of that work. Now, the other weathering we need to discuss here is chemical weathering, and this is when you have different materials that come into contact with rocks, and it's going to create some sort of chemical reaction that will break away pieces of those rocks. Or the first one is a dissolution, which is basically parts of those rocks being dissolved. So if a rock is in water, water being the universal solvent will actually dissolve everything at some point. It does take a long time for certain things. So even if you put a piece of gold in a river, at some point that gold will be fully dissolved away in the river. Now, this could happen over a million years, but it's still dissolving. So all materials that you put in the river will eventually dissolve. When we talk about oxidation or reduction, this is when we have obviously oxidation involves the oxygen weathering. Uh, Most commonly, we can see this in metals. So if we're talking about ferrous metals or irons, then you have iron oxide formed, or it's oxidizing, and this happens in rocks as well. So just about every material that are out there has some sort of a reaction with oxygen, and then these oxidated materials are actually becoming less and less prevalent in their size, and they become smaller and smaller, and that's how soil is formed. We also have hydrolysis and hydration. These are other ways of chemical reactions, and these all involve water either leaving or coming into a material to create the chemical reaction. So when we look at the origin or the original source of most soils, it's rock. And this is like 99% of soils come from larger rocks. Um, Typically, we look at the Earth's crust at some point in our history. There was no soil. There was just Earth's crust, and these rocks were formed by the cooling of lavas and magmas, and they created the bedrocks that we have now. And over time, as water and wind and these chemical reactions happened, smaller and smaller pieces of these rocks were formed until we got to a size where soils were developed. There are three typical rock types. You have igneous rock, which come from volcanoes. You have sedimentary rock, which comes from layers upon layers upon layers of materials settling and then being compressed. You also have metamorphic rock. So again, soil genesis, this is creating soil from the parent material, and those parent materials will be uh, the bedrocks or other rocks that are out there. So that's what you're creating soil from. And when we look at parent materials, we have to look at how things are transported. So just because you have a rock in one place doesn't mean the soil is going to develop in that place. Many times these soils are moved to different areas by the wind, by water. You'll notice wind Aeolian deposits or water, which are alluvial soils. Something that is very common that you'll hear a few times during this lecture are called alluvial fans. These are very similar to a river delta. This is where water flows from a high place into a low place with usually a great velocity, and is able to carry material down away from these higher place into a fan-like structure. And once this fan is there, it spreads and keeps spreading and keeps spreading, creating a river delta, but at the almost the head of the river, the start of the river. But these are also very, very rich in nutrients and great soils to grow in. And you can go to Google Maps and you can turn on the satellite imagery and see these alluvial fans. They're many, many, many miles in certain areas, and they're just amazing how it looks like someone took say a Chinese fan, opened it up, and then you have these soil deposits. When we look at climate, it's a very important aspect of soil development. And the typical things that we need to assess in the climate are the temperature and the precipitation. So temperature is typically those lower temperatures. When I spoke about the frost fracturing, this will get in there, and those really cold temperatures can tend to break rocks apart, because any kind of moisture that's in there that will create these cracks, and eventually these cracks become bigger and bigger and smaller pieces and smaller pieces. We also deal with precipitation, and this is an erosion from the water and the precipitation, then taking some of that parent material with it. Every time raindrop or water is striking these rocks, little pieces of the rock are leaving, or are being little fractures are being created to leave, and these are small pieces. Usually you can't see them. They are not something that is, you're not going to see this huge piece of a rock fall off, but you will see the small pieces of rock fall off. When we're talking about different types of areas, we look at arid, semi-arid, and humid climates. When we start with arid, is basically means dry. So this would be your deserts. Semi-arid would be kind of the midpoint, the moderate temperature, and then humid would be your jungles, your rainforests, areas where you have a lot of moisture. The further you get in the scale away from arid, you get more erosion, you get more soil produced. So these areas are far richer, better nutrients. There's more substance to the soil, so you're able to use these soils more readily in growing and in producing food and producing plants. Go to a desert, things don't grow in a desert, and it's really not only because of the heat and lack of water. It is also a portion of that lack of soil structure, soil nutrients. There's just nothing there for the plants. They don't want anything that's there because there's just not great soil structure there. One of the big formers in soil formations is organisms, and these are typically your microorganisms and plants. So when we're looking at like a plant, not only does the frost fracture these rocks, but you can also have trees that are strong enough to grow their roots into bedrock and into big rock formations, and actually they're strong enough to crack these rocks into smaller rocks and smaller rocks, and eventually additional soils are formed in their place. So again, microbes will have activity in the soil. They will move around. They will create friction. They will start to break down soils. They will actually start to consume soils. Certain things like worms actually will consume soils, and as they move through the soil, and then they are deposited behind them as they go through, and this changes the texture of the soil as well. When we look at mineral soils, these have the highest organic matter content. So these are going to be formed where there's grasslands, where there's lots of vegetation, and these are going to be the best soils. When you're talking about organic matter content, this is the substance to the soil. When you are eating something, you want to have something there to grab onto, and an organic matter is what plants really like to grab onto to allow themselves to be strong and have nutrient capacity. Organic matter holds on to far more nutrients than soil. It has a far greater exchange capacity for different minerals and different things that plants like. Topography can create a lot of uh, things that will help create soils, and obviously when you're talking about slopes, that will help with erosion. So if the steeper the slope, the more erosion you'll have. But we're talking, as you have steeper slopes, you're not going to have the finer particles being produced. You'll have larger particles. The smaller the slope, the smaller the particles will come off of that. And so that's how you are starting to talk about soil formation on slopes. Also, another important thing to note on slopes is it's hard for a slope to soak in water, because the water just doesn't have an opportunity to sit in one spot long enough for it to for these slopes and hills to retain the moisture. We can see this when we're working with plants in various areas, and you say on a golf course, if you are trying to water the fairway, if the fairway is fairly flat, you can have great coverage on your irrigation. When you start to get into the hilly areas or the different topography, different changes in height and elevation, it becomes quite difficult to maintain water in those soils. And so you actually have to manage them differently, and you add different things. And if we go back to that organic matter is really great at holding on to water in those areas. So something to consider, and something that we're going to talk about later on in the class, is adding strategic organic matter and strategic soil into these hilly areas, or areas where water retention is key. So kind of remember that and understand how that can be important when we're talking about soils, and how the plants are interacting with soils. I think we need to be critically thinking about all these different things as you're reading these slides and reading the book, and we're going to see how these different things really play out in, say, a golf course or a landscape setting. Um, Obviously, when we're talking about soil formation, this is happening over many multi-millions of years. So time is probably the most important factor when it comes to creating a soil. Uh, I wish I had the study in front of me, but I was reading about topsoil, and it takes anywhere between 20 and 40 years for topsoil to be replenished. So when we're continually working the soil and we're losing soil, we end up having a problem with having those strong nutrient-rich soils for plants to grow in. It just takes so long for these rocks to become to go from being these big, huge boulders into being, soil particles in that area. Uh, I'm going to be posting a video about the Dust Bowl, and it's kind of an interesting video to watch. And if we think about time, many of the factors that happened with the Dust Bowl was mismanagement of the soils. We got greedy. We wanted to produce more and more crops, so we started to plow under more and more soils. We started to have more and more problems. And after a while, the environmental factors of wind and lack of rain started to deplete these soils, and many acres and huge swaths of earth were carried away by the wind. And this area took years and years and years to come back into being something that was usable again in farming techniques. You had to add in so many extra materials at that point that it became more difficult to do the farming. So proper management, understanding that if we are looking for a short-term solution, it may not always be the best because things take time, and soil is just, it's very, very a slow process to develop new soils and to have more and more soil in your area. Going straight into human activity, kind of what we just talked about with the Dust Bowl, human activity modifies soil very heavily. I wouldn't say that we modify more than nature, but I would say we modify soil more detrimentally than nature does. And this kind of comes in when we talk about land use, and cultivation is a huge one. And that's, we talked about the Dust Bowl, we talked about plowing and having those soils turned and turned and turned and continually used. Well, that's not good for soil. Soil likes to have its defined layers. Soil likes to be in its horizons and have its things, and it really wants to be left alone. Unfortunately, we need to use these soils to sustain ourselves, to grow plants, to be strong humans. So we have to modify the soil. We have to be very careful when we do this. Obviously, we're going to be adding in different fertilizers. We're going to have areas for landfills. We have to put in pesticides, and the least amount of activity that we can put into these soils is to our advantage, because we will not destroy soils. I would say the Dust Bowl was a huge learning experience for many of the farmers in the Midwest. And I would be surprised if we ever saw something like that again, because people now understand how important the soil is and how we really need to take care of it. Getting into the soil profile, this is going to be something very important. The soil profile is what we look at in the soil when we're looking at the different layers. So if we were to take a soil probe into the ground, you could then verify all the different layers. And we will be discussing that more and more with, say, turfgrass growth. There is a certain point where those roots don't grow anymore because there's just nothing there for them. And we'll get into that a lot more during the rest of the class. But just understanding that there's these different layers that make up different soils, and then when we start tilling those layers in, we start to lose the definition, and we just have a big homogeneous soil, as opposed to having the different layers where we can see visually. Some of the things that we talk about here in soil profile is, when we're adding things into the soil or we're taking things out from the soil. So this can be either nature doing this with the wind, or rivers or water, or human activity does this as well. For example, this is a golf course management course program, and some typical practices on a golf course green is to do something called top dressing. And top dressing is basically adding sand on top of the grass so that the grass then grows through the sand and it creates another layer of soil that is added into the soil profile. So discussing those soil profiles, the soil horizons are delineated by letters, and when you look at them, you have the O layer. You have this O layer is typically an organic matter layer, and this can be really evident in, say, a forest. If you were to look at the top layer of a forest, you're going to start to see leaves scattered about. And then if you look right under the level of leaves, you're going to start to see all the other leaves that were there before, and those are starting to break down. But they're becoming, they're not really a soil, but they're becoming an organic matter layer that's on top of the soil. And these organic matter layers are fantastic for growing plants. And these are what smaller plants, smaller trees will then feed on for part of their fertilization, part of their nutrients. And these organic layers are kind of the recycling of the carbon that the tree produces or plants produce, and then you're creating another cycle of this carbon cycle where the plant grows, the plant loses parts of it, it goes onto the ground, and then the other plants that come in behind the big plants will have something to maintain themselves. A really good example of a soil horizon organic layer in, say, a golf course. And it's a great example, but it's not always a positive thing to have in a golf course. And you'll hear this in other classes and in other studies, is a thatch layer is actually an organic layer, but it can be to the detriment of your plants, because the thatch layer will actually rob the root system of your plants of water, because it's going to act like a sponge and it's going to take the water away from where you want to put it, and it's going to allow it to sit there in that organic layer. Moving down in the soil horizon, we start talking about the topsoil. Now, this is obviously the most important layer. This is where that organic layer has deposited some of its nutrients, and the topsoil is going to be your prime, best soil where you're going to start growing most of your crops. Typically, your smaller plants, i.e., grass, shrubs, and anything that is smaller than about a foot tall will not grow past your topsoil layer unless you have a very small topsoil layer. Now, the E layer, this is actually kind of an interesting one. This is kind of a mixing of topsoil and subsoil. So not every soil has this E layer, but if it's there and it's pronounced, it will take these nutrient-rich topsoils and it will take these subsoils where there are no nutrients, and it will start to create a layer in between there where you have some nutrients, but it's really not a strong growing medium. But you will start to have plants that will grow into this E layer, and it will allow it to continue to develop. And in short order, these E layers can become topsoil. So this is how topsoil is created. It's basically these subsoils as they work their way up, or as topsoil works its way down, it starts to add nutrients and they start mixing and they become a stronger and stronger soil for plants to be grown in. When we get into the subsoil, this is where we're having soils that they're soils, they look like soils, they act like soils, but they have no organic matter, they have no nutrients, they're basically devoid of anything that plants would want to use. Typically, this is where we see our aquifer layers. If we have, say, a groundwater table, you're going to end up having those in your subsoils and in your parent material. These B layers or subsoil layers are great because eventually they're going to develop into topsoil. They're going to be great anchoring points for your taller trees because these are going to be deeper, and they're going to hold those taller plants, but they're not going to really create a whole lot of need for your grasses or your other smaller plants. When we get down into the sea layer, this is then called your parent material, and this is kind of borderline being rock or borderline being soil. This is basically a lot of rock, gravel, pea-sized gravel, and these will then start to weather and form into the subsoils. So typically not a lot of soil in your sea layer, but you do have a lot of this parent material that is going to become soil at one point in its life. And then if you get all the way down to the R layer, this is going to be your bedrock. And this is the areas where you have no soil, but could potentially become your parent material for more soil development in the future. So we're going to talk a little bit here about subdivisions in the master horizons, and the master horizons are the top layers of the soil. And this is when you have kind of all these horizons are mixed together, and you're going to deal with having say topsoil in your E layer, and you're going to start to mix these, and you're going to understand how these horizons are working with your plants, and this is going to go back into your soil taxonomy or your soil genesis, and you're going to be able to determine which letter or which soil profile you're looking at. Okay, so this one actually had quite a bit of information, but if we're going to summarize all this, here's where we're at. We learned about the soil body. We learned about the different rocks and minerals that create the soil. We learned what parent material was. This is that material that's kind of soil, but it's not quite into the different sizes of soil that we're looking for yet. But it is the origin of the soils. Climate is very important here. I can't stress it enough for you to understand the wind and the precipitation and how that affects soil development. Also, topography. We talked about how slopes create these alluvial fans and how slopes work with and against water in the formation of soil. And when we come to time, we talked a lot about time and how these soils take a long time to develop. This is very important. And then most importantly, from this whole chapter is I would really like you to understand the soil profiles and understand those different horizons and how those different horizons can act with plants. I would say if you understand and you can look at a soil profile and you will understand how or why, say, your grass isn't growing as deep as you want it. You know, my grass is only growing 2 inches deep. Why is it only growing 2 inches deep? Because there's nothing down there for that plant to go after. You have to start to get different materials down deeper, or you just have to let your soil develop into more and more nutrient-rich topsoils. So I hope you enjoyed the lecture. This is the end of chapter 2. Thank you.